Let's go.
Audio Jungle.
Yeah. I really got the feeling today
Audio Jungle.
that everything is going my way. Now this is what I'm talking about.
Audio Jungle.
Every time I see your smile, it makes me shout. Let's go.
Audio Jungle.
Let's go. Nothing's gonna stop us today.
Audio Jungle.
Get on the bus or get out the way. We're cruising with the radio on.
Audio Jungle.
So turn it up to 10. Here comes our favorite song. Let's go.
Audio Jungle.
Let's go. Let's go.
Audio Jungle.
Let's go.
Hello, it's another Tuesday, and as always, it is IoT Tuesday. I am yours truly, Samuel Adrani. Welcome, good morning, good afternoon, good evening, good dawn, if that's something to be said, wherever you find yourself on the continent. This is another episode of IoT Tuesday. When we come back, we're going to be talking all about IoT communication in today's episode. Don't go anywhere, stick and stay. Okay, thank you for joining us. This is IoT Tuesday, where we talk about everything IoT. For the past couple of weeks, we've been talking about uh, l- connecting various sensors that will be needed for our home environmental monitoring system. If you have not been following, go check out all our social media streams, YouTube, Twitch, and you will see all the previous episodes. In today's episode, we're going to be talking a lot more about communication because once we've gone past the stage of connecting all our sensors to the various microcontroller boards, the next thing for us to do is to think about communication. How do we want to send that information from one board to the other, or even sending information on the sensor values and data from the board to the cloud. So today we're going to try to demystify all about the IoT communication protocols, which layers they work on. It's going to be a bit theoretical, but at the latter part of the show, we'll take a look at what Microsoft Azure IoT has to offer, sorry, in terms of the services we can use on Azure to, enable communication when we're building IoT devices or IoT project. So if you're joining us, let's just get right into it. So, not to bore you too much, I'm quickly going to switch to the bench and show you what we have been working with over the past few weeks. So let's go to the bench. Hopefully you can see this. So let me pan somewhere here so I can actually show you an array of kits. All right, I think this is fine. So what you're looking at now is uh, the various IoT boards, so to speak. Now, the reason why I have all these boards here today is that I just wanted to highlight a few things with all the boards. Um, so let's start from I'll start from the least known and then to the well known. So here, this is the Intel Galileo board. It's one of the early generations of Intel's IoT board. This is Arduino compatible, so you can put like any of the Arduino shields on it from Seed Studio, any of the hat, and that should work. It has Arduino layout, so the input outputs are the same for Arduino. Now, if you take this board for instance, this board actually has Wi-Fi, and then also as you can see, it has the Ethernet port that allows you to connect this to a physical network. So if you were to be using a Galileo, you had options of going either Wi-Fi or going with a physical Ethernet port. So if you wanted to connect this uh, for it to communicate or send data, then you'd have these two options. All right. So let's put this here. Now, then I can talk about the MX chip dev kit. Now, this you might not probably use in an official project because this wouldn't, yeah, you need, to have extensions to use this, but this has all, all on board sensors and all that. So this has Bluetooth, this has also Wi-Fi. So you could also connect this to your Wi-Fi network, and that enables communication from this device to either the cloud or other devices. All right. So let's put that here. And then I'm going to go to, I don't know if you've heard about this, but this is the Omega 2. So the Omega 2 also has Bluetooth, it has Wi-Fi, and as you can see, so these will be the options if you choose to use an Omega 2. All right, this will be the communication options you'd have for using an Omega 2. So you realize that in general, talking about the communications for these devices, the common traits we're seeing here is Bluetooth, Wi-Fi, Ethernet. Now, this is not just it. I'll be taking you through series of the various communication protocols, and then we'll try to see if we can, briefly connect any of this board to the Azure IoT offerings. Now, let's continue. Let's get to the bench now. So now, this this is an expressive if ESP32 ROM. All right, here, as you can see this. Now, this has Bluetooth, this has Wi-Fi as well. So if you're doing any project with the ESP32 ROM, then you know that you had access to Bluetooth. These are also very inexpensive. So depending on the project you're working on, you could go for something like this. Now, the reason why I'm showing all this is that considering that you're building a home environmental monitoring system, you would have various rooms or various points in the house that you are tracking or you want to monitor. And therefore, you probably are going to deploy multiple, sensoring kits or units at different points in the house. Maybe one in your bedroom, one in your hall, maybe one in your kitchen and stuff like that. Now, at the end of the day, you would expect that all these deployments would communicate either with themselves, with each other, or will be communicating their data or values to, let's say, a gateway, a central point. Let's see if I can. I tried this. I tried this a couple of minutes ago, and trust me, it didn't look good. I don't know why, but I just want to see. Let's see if I can. Okay. Let's pick a red pen. I don't know, but for some reason, let's see. Hmm, well, okay. Well, let's just skip this. I had wanted to demo this, but let me just use a notepad for now. Sorry, Paint. Actually, I can use notepad to do this. So, but anyway, let's just stick to what the knowns are. Okay, so let me quickly briefly just bring you to this. So we might have multiple deployments of our sensoring kit, all right, deployed in different parts of your home. Now, these will be collecting sensor values, and these sensor values will need to be sent either to the cloud directly, or ideally you'd want to send all this sensor information to a central gateway, and the gateway actually sends it. So let's assume that here, let's have this. Our this will be our gateway, all right? And then we have one sensor here, let's say in the kitchen. We have another sensor here, let's say in the hall. Let's say one sensor here in the bedroom, maybe one somewhere else, all right? Now, and let's say this is let's have our cloud somewhere here. Okay, this is our cloud. Forget about my illustrations. All right, I'm using a mouse, so bear with me on that. Now, so ideally, sorry about that. I'm trying to zoom in. So ideally, you could either say you want the device to communicate directly with the cloud, okay, this way, which might not necessarily be, a good thing because then you have all your devices talking directly, to the cloud, which is not, ideal. All right. Now, the second option for you is to send all the data values to a gateway. All right. So you're sending all the data values or your sensor values to a gateway. All right. And this can actually be an intelligent edge, which can operate offline. So which means that even without internet connection, this should be able to process whatever, AI or whatever logic you put on this edge, and then only pushes stuff to the cloud as and when needed, or as and when data is available. All right. Now, this is one module you can do. Now, however, there's also probably the need where these these sensors or these deployments need to talk to each other. All right. And how do they talk to each other? All right. So these sensors or these deployment can talk to each other based or using any of these protocols that we're talking about. So this is one of the things I just wanted to illustrate before we move on. So yeah, enough about that. Okay, so we've seen a couple of them. Now I have here um, particle the particle set of controllers. All right, we have the Xeon. All right, we have the this is the argon. All right, I think argon here. Yeah, this one. So this one, this LTE or GSM enabled, and then we have the boron also, which is LTE enabled. So imagine I was using any of these. All right, I could connect sensors to this, and then these boards could communicate to each other based on using any of the protocols or any of the communication services that we've been taking a look at. So that is also for it, and I will try to demo something here for you. I think I showed this before, but I'll try to demo this where I'm using just Bluetooth to control the Arduino 101. And this is just simply to toggle this, and that's via Bluetooth. That's just to show you how easy it is to communicate. Then we come to our Raspberry Pi. If you look closely here, the Raspberry Pi also has an Ethernet port. This also has Wi-Fi. So you can connect your Raspberry Pi either via Wi-Fi or via Ethernet. All right, so that's another option you have there. And then we have the Azure Sphere. We have the Avant kit, and then we have the Seed Studio kit, which has Wi-Fi on board. So you can connect Wi-Fi to any of this. This is one of the secured MCUs currently on the planet, coming from Microsoft. And then we have our Arduino. Now, Arduino has different variants. Now, this is the Arduino 101. The Arduino 101 has Bluetooth and Wi-Fi. All right. However, the regular Arduino Uno doesn't have Bluetooth, doesn't have Wi-Fi. However, it has something called the shield. You can have a Wi-Fi shield, just like the hats we have on this. You put it on it, and that gives it Wi-Fi or Ethernet or yes, Ethernet Wi-Fi capability. So you need to understand the various communication protocols or communication tools available for the various boards, so that when you're choosing a board to use for your project, you know that okay, this is the available communication platform or protocol for me on this board that I can use for my project. All right. So let's let's talk a little bit about the various protocols. All right. So um, let me bring my notepad here so that we can actually talk about this. So I'm going to bring my notepad here, and I'm going to make it a little big, all right? So we can talk through this simply. All right. So let's go this way. Awesome. Now, before we get going, all right, I just want us to talk about a few things. If you're familiar with networking, you understand that the Aussie reference, layers of networking. There are various networks: the transportation, the network, the application, the link layer. Crazy things. We won't worry ourselves, about that. Now, I just want to let me bring a few things in here that I have listed out. So just bringing a few things here. Now let's talk about these briefly. Now, most of these will work, in the link layer if you're talking about the Aussie reference model. For those who are into networking, you understand. All right, let's take a look at this. So these are protocols or or networking or communication parts that are available for you to use within your IoT project. Now, Zigbee is also a standard at the same time, kind of like a protocol, combination of protocols. Now, if you have, I think currently, if you have an Alexa in your house, sorry, not you. I have one here, so I'm just. So if you have an Alexa or modern home automation devices, now these devices in recent times speak Zigbee. So that means that if you have any smart device in your home that can communicate over the Zigbee protocol, it's easy for those two devices to communicate. So lately we have like home automation TVs and radios and all that running on Zigbee protocol. So it means if I have a device that also speaks Zigbee, I can actually send commands to the participating devices in-house. Then Sigfox is also another protocol that is used mostly in IoT. All right. The next one is the low rate, all right, low rate network, which kind of like pulses, but also a very popular protocol or means of communication for IoT devices or IoT deployment. Then obviously we've seen Ethernet, we've seen Wi-Fi, we've seen 2G, 3G, 4G. I put asterisks at the 5G because that is like something I believe is coming pretty soon. And then the LTE communication, mobile communication, all these things are available for you. Now the question you need to ask yourself is, if I'm doing this deployment, okay, where am I doing the deployment? What is the network availability? Is it in an area where there's Wi-Fi? Is it an area where I can get easy access to Ethernet? Is it an area where there is no Wi-Fi but there is mobile signal? So 2G, 3G, 4G, whatever that is. This would inform what board you use and how you deploy your solutions. All right. So bear that in mind. So bear with me today. We're going to talk a lot more about communication, and then we'll try to see if we can visualize it at the end. But in subsequent episodes from today, I'm going to show you how to connect to most of these protocols. All right, and I'll demo Bluetooth today in today's show, and then we'll take it from then the subsequent shows. Okay, so then Bluetooth. So today I'll show you how to connect to Bluetooth because I have a setup here, and I'll show you how I did that with the Blink application. Now then there's also the NFC. All right, the near field communication. You can also use that. Now, some devices have the NFC capabilities and you can communicate by active or passive NFCs. Now, Z-Wave is almost like Zigbee. It's also another protocol or alliance, all right? You can use that also in your application. Then we have RFID, radio frequency, all right? So that's another way you can communicate. I remember in those days when a lot of these things, a lot of the protocols or the communication modules were not readily accessible. We used a lot of radio frequency. You have two transmitter receiver, and then you send the data by serial, and then by RF, and then the receiver takes it. Quite interesting. Now, so someone asked me on one of my shows that is it possible to connect or let Raspberry Pi communicate to, I think, Windows IoT 10 Core and all that? And I mentioned that I think in the very early episodes of this show, we actually deployed Windows 10 IoT Core onto the Raspberry Pi, and then we use it for several, we actually deployed a UWP application on top of it. So yes, it's doable. There is also a way to communicate between, so let's say, um, we know that the Arduino, all right, the Arduino on its own doesn't have any form of um, Bluetooth or all right. However, I can physically connect pins from the Arduino onto, let's say, the Raspberry Pi or to the Sphere and actually send data through one of those pins or ports too. So that's also another way to, enable the communication in here. Now, so I want to talk about some common application layer, um, pro not protocols, but application layer stuff that you use for communication. Now, one of them, let's go here. So I think I can delete the whole of this. So let's talk about HTTP, all right, /s. Now, this is another way, all right, you can actually, so this works at the application layer. So if you have applications running on your, in your IoT deployment, the applications can communicate over HTTP, all right, so or HTTP, yeah. So you have a simple web server deployed on your Raspberry Pi. You can actually use HTTPS to communicate between your Pi and maybe some other devices that are communicating, to it. That's another way you can use that. Then we have something called the, let me bring this here. So this is called the Constrained Application Protocol. Now, this is mainly used for machine-to-machine communication and uses the UDP communication, UDP packets. All right. So if your deployment is more or less like machine-to-machine or device-to-device, you could use this application. Just like it also has like HTTP verbs like get, put, set, delete, and all that as well. All right. Then the next thing we can use is WebSockets. All right, in terms of communications, you can also use WebSockets. Now that allows you to communicate over a single socket. All right, so this also enables you to send messages between a client server, environment. So that is another option you have if you want to actually do that. Then we have, I mean, this is the popular one that I'm sure most of you be asking, why haven't you talked about this? Is the MQTT, which is the message queue telemetry transport. All right, this is like used in an area or in an IoT deployment where the board itself has limited constraints in terms of memory and resources. All right, MQTT is the best thing. It uses what we call the MQTT or message brokers, which serves as the server. So messages go through there, and then you can send it out. This uses more or less like the publish subscribe module where there's a publisher and a subscriber, so your sensors can be publishers sending to the server, and you can have other deployments being like subscribers that are subscribing to the sensor values that are coming. So that is another module you can also use. And then we can talk about the extensible messaging and presence protocol. Now, this is used for actually streaming real-time like XML data. This is very useful if you're doing applications that involve video, chat, messaging, or multi-party applications. This will be the protocol to use. Now, quickly out of this, let's look at the way various communication modules we can have. Okay, we can actually talk about message to message, or sorry, machine to machine, or sometimes called device to device, or you can have device to cloud or cloud to device. Let's add this here so that device to device. Yep. So these are the various uh, modes of communications that you can have when you are doing your IoT deployment. All right, cool. So with this out of the way, I just wanted to elaborate this. So I've talked about MQTT, we've talked about Zigbee, we talked about the constraint application protocol, we talked about, oh yeah, so then the other one is the advanced message queuing protocol, which is AM QP, all right, advanced messaging protocol. And then we've talked about the LoRa, we've talked about the radio frequencies, the XMPP, we've talked about Wi-Fi, Bluetooth. So all these are okay communications available for you to use, all right. Now, before we jump into the Azure one, let me now take you here to the board. Let me take this out for a minute and let's connect this. Hopefully this is connected here. Cool. I hope I have not messed up the code. So I just connected this. Hopefully you can see this. Let me do it this way. So yeah, you can see the lights properly. Cool. So I'm going to open my Blink app, and this is just to illustrate and show you that I can actually use just communicating between um, my board and my phone using Bluetooth. So I have Bluetooth enabled here. So if you look closely, I'm just going to show this. Hopefully this is seen. Yep. So this is a Blink application I have done that uses Bluetooth. And because this Arduino 101 board also has Bluetooth, I've actually programmed it that it can communicate with this board, all right, and then send commands from this board to the Arduino board. So as you can see, I have 1, 2, 3, 4 lights: red, green, yellow, and white. So I have mapped the same thing here on my phone using the Blink app, okay, right here. So if I move, let me actually just put this down here. All right, and then if I should tap on the yellow light, as you can see, the yellow light just went on. All right, if I tap it, it goes off again. If I tap it, it's back on. Tap it, it goes off. If I use the red, see that now the red LED comes on. Actually, let me lift this up because I have my lights, my streaming light here. It's quite bright, so it's whitewashing everything. So let's do it this way instead. Yeah, exactly. This is more like it. So and let me bring this somewhere here. So now when I press this, as you can see, yellow on, red, red off, green, and the green comes on. All right, and then the white. Okay, so it looks like let's see. I probably have. Okay, I think I miss. Let me reconnect the white properly. Let me turn it off first. So the white is supposed to be here. Let me get the anode and the cathode right. There you go. So now the white is also working. And this is just basically okay. This is just and I can turn all of them on and turn all of them off. Now this is basically using the Bluetooth, all right, on my phone and sending a signal to the Bluetooth on this board. All right. So let's see if I can just quickly go here. So this is how it works, all right? So using the Blink application, I could just go to add and then look at the widget. I could look for any of these widgets. I promise to have this connected to my phone in a subsequent episode and show you Blink properly. So there are a lot of there are a lot of pre-built stuff, webhooks, a lot of stuff going on here that I can easily, let's say, pick up. Let's say let's see. This can be an LED. So I can pick an LED and put it here. And then now on this LED here, I need to program which pin this LED is going to work on. All right. So I can select which virtual pin. Now, whichever pin I select here is going to correspond with the pin on the board. So what the Blink allows me to do is that once I select this and I set it up, it's going to generate a script or a code for me to run through my Arduino IDE onto this board, and then it establishes the communication between my phone and then the board. All right. So let me just cancel this. Right. Yep. All right. So that is a very simple way, all right, of communicating using Bluetooth with a star. Now it could be SMS. So another thing we can explore is that for one of the particle kits that actually support GSM, I'll put a GSM SIM in it and I'll send a text message. And I could interpret that text message to do something when it gets, when the message reaches the kit or the board. All right. So that is one thing to do. Now for the next part, um, let's jump right into, let's see, there you go. Open this up. I want to, okay, so now let me bring this in view and let's go back here. So now let's talk about Azure for a bit. Now, as you know, I do a lot of stuff on Microsoft Azure, so forgive me if I'm sounding biased, but I like to do most of my proofs using a platform that I'm very familiar with. So hence this choice. Now, so Microsoft Azure has offerings for IoT as well. And as we're talking about communication and how we can let the project we are building communicate with, whether device to device or cloud or whatever that is, we can't leave out the Azure IoT offerings. All right. So under the Azure IoT offerings, these are the products and services that Microsoft has to offer when it comes to IoT on the Azure platform or Azure platform or Asia or whatever that you want to call it. So, so first of all is the IoT Central. So IoT Central, simply put, is, let's say, an augmentation of all the services you will need to deploy an IoT infrastructure. So talk about messaging, all right? Uh, so talk about messaging, all right? So your messaging, your authentication, your security, all that, everything, and then your dashboards, all right? Everything put together is what is Azure IoT. I think I have talked about Azure IoT in in previous episodes, so go check that out. So Azure IoT provides you this offering, all right? Just kind of like a one-stop shop. Just go create your tenant, create your project, create a template of your devices, and then mock up the data that is going to be coming, deploy a real device, provision it, and then you can start securely sending data to it, and you can do your analysis on it right on top of it. Then Azure also has what we call the IoT Solution Accelerators. Now, what the IoT Solution Accelerator is, it's just kind of like a set of templates which are industry specific. So let's say energy, government, agriculture, different sectors that have pre-made templates that you can pick, fine tune for your own, let's say, proof of concept or prototype. All right. Then there is the IoT Edge. Now remember in the diagram I just drew, the IoT Edge is an offering for you to extend the intelligence of the Azure IoT to edge devices. So you could actually deploy an edge device, which is your gateway, to have all the intelligence it needs to process server data, sensor data that comes to it. That's the Azure IoT Edge. And then the Azure IoT Hub, this allows you to connect, monitor, and control like billions of IoT assets, devices, any smart thing, because this is the hub that connects with it. Then you can talk about the Azure Digital Twin. Now, Digital Twin is an offering from Azure that allows you to actually model digital versions of physical things that exist. So I could actually, let's say, create a digital model of a building, okay, or a car, and then I can manage that physical car through its digital twin. So anything that's happening to the digital twin indirectly is happening, translate that information to the car. Now, this is because not everything has, so to speak, let's say a microcontroller board like this. So the digital twin is going to act as like the intermediary to affect those things. Then there's the Azure Sphere. So the Azure Sphere, I have shown you two kits or two boards. This is the Advent version, and then here this is the Seed Studio version, which is actually one of the simple and secured, highly secured microcontroller units today on the planet that you can use to build secured application. Then there's the Azure Maps, which is just simple and secure location APIs you can use for your IoT services. So these are the services that are in offering by Azure. So think about it. You to get started, as obviously we've connected our sensor data, we have an idea of the various communication protocols we want to use, and now we have an idea of what Azure provides us. So in subsequent episode, I'm going to show you first of all how to connect to these various Azure services. First, we'll be connecting to the Raspberry Pi. We'll connect the Azure Sphere, and then we'll try to connect the ESP32. All right, and then we'll look at how we can also connect the particle board to Microsoft Azure. Now, if this sounds interesting to you, make sure you connect to our the channel, subscribe, like, share, hit the notification button so that when I release a next video, you would have access to that video. Until then, this has been a short episode on IoT Tuesday. Sorry for no demo today. Actually did a demo but no hands-on today. But in subsequent episode, we're going to see hands-on how to do this. If this was interesting, send us a like, send us a feedback. Let's know how to build it. Have a wonderful evening, afternoon, morning, dawn, wherever you find yourself. And let's do this again next Tuesday. Safe.